Everybody uses cuvettes all day long, every day. If you're doing UV-Vis, near-infrared, fluorescence, spectroscopy, CD, whatever, we all use them, right? But have you ever really taken time to think about some of the inefficiencies of these and why they are so not useful for samples which are not perfectly clear? Well, again, I'm going to pretend that this is a source of light and it's hitting the sample and it's traveling through. What are some of the things that you notice straight away? Obviously, a very tiny portion of the sample is involved in the measurement. Everything below the Z height is wasted. Anything above the Z height is wasted. And critically for this conversation, if something causes this focused beam of light traveling through the sample to the awaiting detector to scatter, then the detector is going to see much less light than you need it to get the correct answer. So what's the alternative? Well, one alternative, people will put an integrating sphere here in order to capture all of the light. But we, many years ago, came upon a technology that we like very much, which is called an integrating cavity. And it is a chamber in which you will pipette your sample, not put it in with a test tube, which allows the light to travel in through a very intentional port in the side of the integrating cavity. And that light source will flood this entire chamber with light. And the only way that that light can escape, there's of course a sample compartment lid on here. The only way that this incoming light can escape, which by the way is illuminating 100% of the material that you've got inside of here, is through a port here directly to the detector. So there is zero light lost to scatter, which makes this integrating cavity an ideal situation for working with whole cells, with proteins which are aggregating, nanoparticles, things in adjuvants or other types of viscous sample buffer, rather than what you're limited to here, which is a clear buffer, which of course is never clear. How do you clean this? Of course, you've got your ways of doing it. How to clean this? You simply take your material out and then you inject your cleaning material. It might just be water, it might be detergent, it might be an acid, it might be a base, and you do that 2 or 3 times until it's clean. How do you know that it's clean? Make a measurement on the UV-Vis spectrophotometer and see if you're getting a nice 0 reading. And if not, do another clean cycle and or rinse cycle. So if you're interested in learning more about an alternative to the quite wasteful cuvette that we still use for a lot of applications, but cannot use for light scattering samples, let's talk.